So now, how can you be able to change the base of the log? Let's say we have log b of x in this case. How can we have this, let's say, to be, let's say, a base of, should be a log of base m? How can we change the log of base b and being the log of, let's say, base m? How can we have that? So now, in this case, rate actually this expression being equal to, let's say, s8. In other words, we should have to express this actual expression into what we call the exponential function. Should be exponential expression or the exponential equation. So in this case, we'll have log b of x and is equal to z. So now in this case, we should have to make x as the subject formula so that the actual equation should be in exponential form from the logarithmic form. So in this case, having z, it is the same as times 1. Hence, according to the properties of the logarithms, we'll have log b of x and being equal to z times now log b of b, of which this is the same as log b of x, which is equal to log b of b to the power z. Now, antilog both sides will have x is equal to, now should be b to the power 2. Now should be to the power z rather. So that's how we change from logarithmic form to exponential form using that order. So now, we are supposed to change the base of the log from base b to a base m. What is the essence behind? So now we use the exponential form of the equation, which is this. Then now we're going to introduce a log of a base m in both sides. So have it as log m of x, and which is equal to log m of b to the power z. Then according to the laws of logarithms, now we have it as log m of x, and which is equal to z log m of b. And upon making z as the subject, we have z is equal to now log m of x that divided by log m of b. So now, which means having actually log b of x, you know, this is the same as having it as, and that should be log m of x divided by, and that should be log m of b. This is the principle behind. So now, on the same case, this is the same as ln x of should be ln b, if we are to express this in terms of the natural log. How about we have this? Let's say we have the log of 5, actually log 5 of, let's say, a 6. How can we have this to be, let's say, of base 2? So now principle remains the same. We'll have to express this in form of the exponential equation, in the sense that we'll have it as z is equal to log 5 of 6, and of which this is the same as having it as log 5 of 6, and which is equal to z times 1. Now in this case, we'll have it as log 5 of 6, and which is equal to z log 5 of 5. In this case, we'll have it as log 5 of 6, which is the same as log 5 to the power z. Now, anti-log both sides, we can have it as this. So now we'll have it as a 6, which is equal to 5 to the power z. Now this is the exponential equation or expression. So now from there, we'll have to introduce the base of our interest, log of the base of interest in both sides, we'll have log 2 of 6, and which is equal to log 2 of 5 to the power z. Then making z as the subject, we'll have it as log 2 of 6, and which is equal to z, and log 2 of 5, of which the z will be given as now log 2 of 6 divided by should be log, now should be 2 of that of 5, and of which it means having log 5 of 6, this is the same as having it as log, and that should be 2 of 6 divided by log 2 of 5, and of which this is the same as ln 6 of ln 5. So keep that in mind. So now how about if we may have this case? Let's say we have log of, let's say 10, no, let me have it as 20. Let's say we have log 20 of, let's say m. Now we wish to have it as in terms of base, let's say 5. So now principle remains the same. Express this in terms of the exponential equation, in the sense that we have log 20 of m, let's say it is the same as z, and of which this is the same as log 20 of m, which is equal to z times log 20 of 20, and of which this is the same as having it as log 20 of m, and which is equal to log 20 and of 20 to the power z, and of which you have it as upon and looking both sides will have m, and which is equal to 20 to the power z. So that is. Then next from there, we'll have to introduce the log of the base of our interest in both sides. But as it stands there, it means we have expressed log 20 of m as the exponential function as that one. So we have expressed this to be an exponential form, which is given as this. So in this case, we'll have to come back and introduce log 5 of m, which is equal to log of 5, and that should be of z, no, should be what, of z, and should be log 5 of 20 to the power z, and upon making z as the subject, we can have it as log 5 of m divided by, now should be log actually 5 of, that should be 20. So in this case, this is the same as having it as ln m and divided by ln of 20. So that's how we change the base from the one base to the other base in that case. Let's say we have this case. How about if we have, let's say it should be this. Let's say we have log 10 of a. So now let's think of having this to, let's say, a base 5. So in this case, principle remains the same. We'll have to write this one to be whichever the variable it says in. We'll have log 10 of e, which is equal to z, and we'll have it as times log 10 and of 10. Now this is the same as log 10 of a, which is equal to log 10 the 10 to the power z. Upon unlocking both sides, we'll have it as a is equal to 10 to the power z. Now let's think of introducing the log of our interest of the base in both sides. Now you'll see that this is the same as having as log now should be log 5 of e, which is equal to log 5 of 10 to the power z, and on the same interest. You can see that we'll have it in this case. So now we'll have it as, upon making z as the subject, we'll have z is equal to, now have log 5 of e divided by log 5 of 10. Now we'll have that understand. Of course, we can also have it as ln e over ln 10, of which ln e is given as 1, we'll have 1 over ln up to the 10. We'll have it as ln 10. Now, in a general sense, and this is true for even if we can have here other base other than 10, we can also have, let's say 6 or let's say 20, whatever the base may think about. At the end of the day, we'll end up having this. So what is the general sense? You can see it from here. So at the end of the day, the general sense you can see from there is that if we have, let's say log, if we have log a of x, having this, let's say to whichever the base, let's say the base b, or have it as log b of x divided by log b of a. We'll have that understand. And for your information, let's say if we have log 2 of 3, you see that if we think of expressing this to base 10, at the end of the day, what I'm going to have is log 10 of, let's say, a 3, or have a log 10 of 2. This is what I'm going to observe, as you can go back in the examples that we have recently looked up to. And also in the same case, you should also get it that if we have log of, let's say, a base 10 of a, at whichever the case, in whichever the base of our interest, at the end of the day, in terms of the natural log, we'll have it as 1 over ln 10. And to try this, let's say we have log 2 of a, let's say we have log 5 of a, let's say we have log 20 of a, let's say we have log, let's say 7 of a. You also end up having the same cases. So try to verify those aspects you come across with. So now, let's say we have this case. Let's say we have log of 2, log 2 of 10, and let's say times log 10 of 2. So how can we be able to simplify this? So at the end of the day, you can see that these actual expressions has got the different bases. So hence we should have to change the bases to be the uniform. In this case, we should have to change this to have the base 10. So in this case, this will be given as, now having log 2 of 10, you see that this is the same as having it as log 10 of 10 divided by log 10 of 2, using the principles of the changing of the log of the bases, the changing of the bases of the logs. Now in this case, we'll have it as this. Now we'll have to substitute this onto here, so which means we'll have it as, now what is the log 10 of 10? We'll have it as 1, so which means we'll have it as 1 over log 10 of 2 times log 10 of 2, of which this will cancel, we'll have it as 1. So keep that in mind. So now let's think of having this kind of equation. Let's say we have log of, let's say, ax, and that plus, let's say, log of, let's say, log 1 of, actually 1 over a and of x. So now how can we be able to simplify this? So now this expression has got the different log as this one is. Then now we should have to express this to have the log as the other one is. So now having this one, it is the same as having it as log of 1 over, should be log 1 over a of x, and divide by log of, should be log 1a, actually 1 over a, and that should be of a. So it should be of a, and plus, now we'll have it as log 1 over a and of x. So now let's think of having this as the single fraction, so which means we'll have of 1 here, and that corresponds to have it as this. What is the common denominator? We have it as log, should be log 1 over a of a, and here we have plus, and that corresponds to have it as, have log of x, and that should be this. Now log 1 over a of x, and times should be log of, should be log 1 over a, and should be of a, because having 1 into this, or have it as the same times that one up. Then on the same case, we'll have this into this, we'll have it as 1, and 1 times the numerator, we'll have log 1 over a of x. So now there is no a property that actually tells us how we can be able to simplify this. Therefore, as you can see on the numerator, actually on this case, on the numerator, we'll have the common denominator, should be a common factor. So what is it that a common factor? We have it as log 1 over a of x, and the times we'll have 1 plus, now we'll have it as log, and that should be log 1 over a of a, and of which literal divide by log 1 over a and of a. So what will go next? Now you should have to understand that having 1 as it stands there, according to the properties of logarithms, it is the same as having log 1 over a of x. In this case we have it as log 1 over a of 1, because actually, and that should be of, not as 1, but should be of 1 over a, and this is a plus, or have it as log of, actually log 1 over a of a, and which is divided by log, and that should be 1 over a of a. Then what will go next? Now further using the properties of the logarithms, and since we are adding inside there, that is the same as having it as log 1 over a of x, and what is happening is that we'll have it as log, or actually 1 over a, and now we'll have it as times 1 over a, and times, and that should be a. So in the same case, we'll have it as this, and being cancelled this, and of course divide by, that is log of 1 over a of a. And what will go up next? So now what will happen is that we'll have it as this now, so which means we'll have it as log 1 over a of x, and which is now being given as Now log should be 1 over a of 1, that which is divided by log of should be 1 over a, of which this is itself according to the properties of logarithms. So at the end of the day, we'll have the solution itself. So that's how we should have to simplify that one in that case. So now let's say this is the case. We have log 2 of 3, and let's say times, and that should be log 3 of 4, and times, let's say log 4 of 5. So now how should we be able to simplify this? So now as it stands here, we should have to express this and also this to have the base form. As it stands there, we should have the base form. So what will be this one be like? So now having this, it is the same as log 4 of 3 divided by log 4 of 2. In the times, having this, it is the same as having it as log 4 of 4 divided by log 4 should be of 3. In the times, now we have it as log 4 of 5. Now we have them in the actually same base. So in this case, we know that this is 1 in that case. Of course, this is 1, so should be this is 1, and I'll be able to cancel this, and this can be cancelled. In that case, it means we have it as now should be log 4 of 5 divided by log 4 of 2. Now this is the solution and that for the case. We cannot be able to simplify further from that one. And now let's say this is the case. Let's say we have a log, let's say a of x, and that divide by, let's say, log ab, and that should be of x. So now, how should we be able to simplify this? So in this case, it is either we should have to express the expression to have, let's say, both of log a, or else we can have both of having log a as well as the b. So now let's think of expressing this to be in a uniform base, which is log, let's say, a. So which means we should have to express this to have that of log a. So in this case, we have it as log ax, and that divided by, what is this in our log a? We'll have it as log a of x, and that divided by log a of ib. That is given as that. Then in this case, this is the same as having it as log ax, and divided by, of course we have over 1 here, divided by log ax, and over log a of ab, and of which we'll have it as this, using the properties of the fractions, the way we deal with the division of the fractions. Now we'll have it as log a of x of 1 times, we'll have log a of ab divided by log a of x. This and this will cancel, we'll only have this. So that would be the solution and for that case. And of which you may be tempted to say, of course this will be the solution. That is, we'll have the solution given as log a of ab. You may be tempted to say, if this is the case, then you may have it as log a of a, let's say like this, then you may say this is equal to 1. In other words, these are different. You'll not be able to say that having, let's say this case, it is the same as having it as log a of a should be log a of a times b. Then you may say this is 1 times b. No, those are different things. You should not have to actually tamper with the base of that case. So there are several questions that you'll be coming across with, and that are to do with the changing of the bases, but principle remains the same. And I actually make these videos, and basically I can make videos for you to actually to understand and get things easier. So if it happens that you like my videos, so please don't forget to like or comment and also subscribe to my YouTube channel. That's the only way you can be able to, that's the only way you can support the actually a progress of the channel GP Analytical School of Science. Thank you.